Alrighty, everybody, so let's go ahead and jump into a new topic. We're going to talk about transformations of exponential functions. And the first thing we need to talk about is the horizontal translations, okay? And then we'll talk about vertical translations. So let me go ahead and create my graphs. Alrighty, there we go. Now, for horizontal translations, when it comes to exponential functions, a point that we're going to look very closely at is the point 0, 1, okay? Now, 0, 1 is important because it's a whole number coordinate point that we can use when applying transformations. Now, another thing to note is that there is an asymptote for these exponential functions, and that asymptote lies on the x-axis. Now, when you go to draw your exponential function, it looks like this, okay? Now, if you were to move this guy to the left or to the right, okay, and also just for verification, this is f of x is equal to e to the x. So if I want to go left, this would look something like e to the x plus 2. Okay, so that means my graph, okay, is going to go to the left 2 units, so 1 and 2, and it's going to do that. Now, of course, the asymptote still exists on the x-axis. It does not move, okay? It doesn't move to the left or to the right, okay? Now, if I want to go to the right, I have the f of x is equal to e to the x minus 2. Then that means I've got 1 and 2. And so, boom, it's right there. And we've got a graph that looks something like that, okay? Now let's talk about the vertical translations. All right, here we go. So if we were wanting to go up with an exponential function, okay, starting at the 0, 1, let's go ahead and shift this guy. F of x is equal to e to the x plus 2. So notice how the addition or the transformation is not inside the exponential, okay? It's not inside the exponent. So this right here tells us we're going to go up. So we're going to go 1 and 2 up. And so we have something that looks like this. Now this is important because our asymptote is affected by the vertical translations, meaning the asymptote is now here. Okay, it's at 2. So same thing for going down. So say I had e to the x and then minus 2. Then starting here, I would go 1 and 2, so I'm now here, and that also means that my asymptote went down to, and it looks like this, okay? Asymptote being now at -2, okay? So just be aware that the asymptote is not affected by the horizontal translation, but it is affected and does abide by the vertical translation, okay? So just be aware of that. Now let's talk about the reflections. Alrighty, so if we wanted to reflect something across the x-axis, that means we're going to now have it crossing through this point at 0, -1, okay? So it's going to flip down, okay? Now, if we had a reflection across the y-axis, it will still stay at the 0, the 0, 1. But now, instead of it going up and to the right, it's going to go down and to the right like this, okay? Now, let's go ahead and talk about the vertical stretches and the vertical compressions. Alrighty, now for this part, you're going to have to pay close attention to what's going to happen when we apply these vertical stretches and we apply these vertical compressions, because it does modify where our starting point is going to be. Because we have to talk about something. When we do e to the 0 power, that's equal to 1. That's why we say we're starting at the point 0, 1. Okay, that's this point right here. Okay. Now, when you do e to the 0 power, but you decide to stretch it by like a 2, e to the 0 power, okay, breaking it down. Let me get back to my pen. You have e to the 0 power times 2. Well, e to the 0 we said was 1, so then I have 2 times 1, so that's equal to 2. Okay? With that being said, our new starting value is no longer at that 0, 1. It's now at 0, 2 right here. So the idea is this, is that a vertical stretch is not shifting it up 1. Please understand that. A vertical stretch is not a shift up 1, okay? Because it appears that way, but what you have to understand is vertical translations also affect the asymptote, okay? That was another stipulation. But in this case, you're going to notice that the vertical or the asymptote itself is not affected. It's still going to rely or stay on the x-axis. So please be aware of that, is that we do move our starting value up, but that doesn't mean that it was shifted. Same thing for a 1/2. If I do a 1/2 e to the 0 power, that's 1/2 of 1/2 times 1, which is 1/2. Well, that means it's, the starting value used to be at that 0, 1. Well, now it's at the 0.51. But that doesn't mean that I shifted it down, okay? The scalar is affecting the numbers, okay, and causing it to do that, but it's not the reason, okay? Now, also, too, I should go ahead and be probably drawing these a little bit nicer. So for that vertical compression, it's going to swing through that point, but then it's going to go out a little bit more and then start to carry back up. The vertical stretch, I did draw that right. You are going to pass through that point, and then it's going to go really fast because you're stretching it upward, okay? Stretching it upward. Now, let's talk about the horizontal stretch and compression. Okay, so for horizontal stretches, it'll probably look something like this. You could do e to the 1/2 x, and then for compression, you'd have like e to the 2x, okay? Remember, these types of translations are reciprocals, okay? They're opposite. The reciprocal of 1/2 is 2. The reciprocal of 2 is 1/2. And if you were to look back on what we just talked about for vertical stretches and compressions, if you mirrored that over, you would notice that the reciprocal of 1/2, 2, well, that would have been a stretch, right? Because that's a number greater than 1. And if you were to do the reciprocal of 2, that's a half. That's a number that exists between 0 and 1. And so that would be the compression. Now, looking at this right here, believe it or not, this does not affect the overall placement of the original dot. So the parent function, okay, is at 0, 1. Well, with horizontal stretches and horizontal compressions, they're still going to exist at 0, 1. The reason for that is because if you were to do e 1/2 times 0, well, what's 1/2 times 0? Well, that's still e to the 0, so that's still 1. And if you did e to the 2 times 0, and then you did e to the 0, that's still 1 as well. So as you can see, the horizontal compression doesn't do that, and I don't want to use that word, but the shifting part, okay? It doesn't move the graph up or appear to move it up, okay? It's still going to stay that way, but it does affect the graph. The horizontal stretch, the way it's going to look is it's going to cross through and then go up. Then for the horizontal compression, okay, it's going to go through and then start going up a lot quicker, okay? It's going to go up quickly, and hopefully I can maybe do that. That might be a better representation. So as you can see, horizontal compressions look more like a vertical stretch, and horizontal stretches look more like vertical compressions. Now let's go ahead and do some examples and maybe describe some of these transformations together, okay? Alrighty, so let's try this one on for size. If I were to do f of x is equal to 5e to the x plus 1. We're doing this one because it has that shift up 1, but then it also has that stretch that I talked about, okay? So when looking at this right here, a lot of what we could do to make our lives easier is we could apply those transformations based upon those tables. So if I did it based on the table 0, 1, that was my x, that's my y. And then we had this one and this one. Now we're only going to apply it to the 0, 1 because that's the point of interest. And then from there we can do the other transformations. Remember the first one, the first box was always add, subtract, or not add, subtract, but multiply and divide. And then of course the second box was the add and subtract. Now because we are doing multiplication, okay, to the outside, okay, remember everything on the outside goes to the y's. So everything on the outside, this is y. Everything on the inside would have been for x, okay? So for here, I'm going to multiply by 5. And I'm not going to multiply anything to my x values because there's nothing to do, so I just have 0. Now, 1 times 5, that's 5, right? Now, looking at the next box, okay, this would have been, is there anything adding or subtracting to my x? No, so I still have 0. But then the 1, I'm going to add 1, right? Plus 1. So what's 5 plus 1? That's 6. So if you were to go ahead and look at the graph, you should have your new point of interest passing at 0, 6. So I should do 1, 2, 3, 4, 5, 6. So it's passing through here. And that also means since I shifted, okay, my graph up 1, okay, that means the horizontal asymptote went up 1. It didn't go up any further than that because remember, it's the vertical translation that affects the asymptote. It's not the stretch, okay, or the compression. So be mindful of that. So then tracing it through, I'll use a different color. It will look like this. Okay, it'll look something like that. And you can always check your work, verify it on the calculator and make sure you're good to go. But it should look like that, okay? Now let's do another example. Let's try this one. So for this one right here, if we were to look at our boxes, so we only really care about the 0, 1. Let's first talk about them. The negative in the very front, that's a reflection across the x-axis, right? And then the 1/2 is the vertical compression. Now, inside the exponent, the x plus 2, that's a horizontal translation. That's going to tell us to go to the left 2, right? And then the minus 3 on the outside, that's telling us to go down 3 units. So remember, anything on the outside, that corresponds with your y's. Anything on the inside, meaning the exponent inside here, that goes with your x, okay? Now, of course, we're multiplying. So this first one goes with the multiplying. Now, it goes to the y's. So I've got my negative 1/2 there. And then the other one, minus 3, goes over there. Now we have to be careful when we're doing the adding and subtracting box. Remember, you have to do the opposite. So I know that says plus 2, but in all actuality, we have to do minus 2 because we're going to the left. So when we modify this point, I don't do anything to the 0, right? So it still stays 0. And then for the 1 times a negative 1/2, that's going to put me at a negative 0.5, right? Then we're going to add, or not add, but subtract 2, okay? So 0 minus 2 is negative 2. And then negative 0.5 minus 3, that's going to be a negative 3.5, okay? And so looking at that on a graph, okay, our point of interest is always the last box, right? So I've got 1, 2, and then 1, 2, 3, 4, and then it goes right in between, right? At the 0.5. Now remember, because it was a reflection across the x-axis, that means he's going to be curved down, right? He's going to be flipped over. Now, where is the asymptote, though? Remember, the asymptote is affected only by the vertical translation, right? So that means the vertical, or not the vertical, but the asymptote shifted down 3. So it's located right here. And there you go. That's the transformations, okay? Now, I think we could do one more, and then that'll get you guys up to speed here. All right, let's try this one. So let's do our boxes. Oof, that last box needs some work, but that's okay. Alrighty, so remember, anything on the outside is going to go to your y's, right? And so nothing here, so don't worry about that, but we should care about this piece. And then, of course, this stuff on the inside, this all goes to the x, right? So let's just do the y part, okay, just to show where that's all at. Nothing's going to happen to the first box for y, but we are going to add 4 on the last one. Now, we can now move towards the blue part for the x. We are going to be multiplying the x value by something, but it's not going to be by a -2. It's going to be by a -1/2. Because remember, it's always the opposite. It's the reciprocal. And then, of course, for the last box, you're not going to be adding 3, but you're going to be subtracting 3. So just be aware of that. Now, let's kind of talk about the transformations as well. The negative inside the reciprocal, the negative in front of the 2, that is a reflection across the y-axis. So let's be mindful of that. The 2, that is a horizontal compression of 1/2, hence the reason I wrote a 1/2 on the second box. Also, the x plus 3. The plus 3, that's telling us we're going to be going to the left 3. So that's why we did -3. And then the plus 4, that's telling us to go up 4, right? Now remember, that plus 4, that's what's going to be affecting the asymptote, okay? It's not the stretches or the compressions of either, okay? So just be mindful of that. Also, remember, horizontal stretches and compressions do not affect the overall starting point of that initial 0, 1, but we'll see the transformations applied by doing the boxes. So what's 0 times a -1/2? Well, that's still 0, right? And remember, that's why I said it doesn't really affect the overall placement, right? It's still just going to be at the same 0, right? And so then we have a 1 there because nothing's happened to the 1. Now let's do 0 minus 3. That's going to give us a -3. And then 1 plus 4, that's going to give us a 5. So that's actually a really solid, nice point. Okay, so when we go to graph, I have it at 1, 2, 3, and I'll go one more 4, and then up 5. So 1, 2, 3, 4, and 5, and then I'll put 6 just so we can see. Now the point is going to be right here, okay? And we said that it was reflected right across the y-axis, so that doesn't mean that it's going to be flipping down, right? That means it's going to be just the opposite, right? It's going to be going like this, right? And I should be mindful of where that asymptote is. And let me go ahead and put in that asymptote. Let me see here. So we said the asymptote went up 4, so 1, 2, 3, 4. So it's right here, and that's actually going to be helpful. So let's see here. Let me get my blue. We got that. There we go. And that's a lot better. There we go. So if there's any questions, please reach out to me. Let me know if you're running into any, issues on the homework. Hopefully that was very, insightful on how we handle those types of transformations. And just be careful of those vertical stretches and vertical compressions, okay? Just be careful of those. Alrighty, guys, let me know if you need anything. Bye.